Our next example in this animated tutorial of C++ standard library containers and algorithms demonstrates vector list operations. So this is a longer example of a little function that manipulates a vector of strings. So we are just about to enter function f and create a vector named fruit with 2 apples. So we begin with 2 apples. So of course this is constructor. This time the element type is standard string, and then we use pushback, series of pushback operations to create other types of fruit. So we just, you can see that we add and add and add and add, and finally we end up having this vector populated with a series of strings like this. Then we invoke copy constructor to create an exact copy of this vector. Okay, so now we have fruit2, which is a copy of the original one. Now we can use algorithms of C++ standard library, and this is an example of an algorithm named sort. So here we invoke, we're just about to sort vector fruit2 in range from the beginning to ending. Okay, so from the very beginning of the vector to its ending, we're just about to start the sort. So the sort determines the by comparing the elements, it determines where to start, and uses some kind of balancing sort algorithm that essentially is rearranging the order of these elements as you would expect by a sort algorithm. Of course, the strings are compared by equal, not equal, and less than operator, and of course standard library string provides or overloads these operators, so the sort algorithm by default is using less than, and makes comparisons of strings in lexicographical order. Of course, notice that the grapefruit is ending up at the top of the sorted container, simply because it's using an uppercase version of character G, which of course is in earlier part of the character encoding table, so that's why it ends up to be on top. All other strings happen to be all lowercase, so they're happening next. And then another demonstration of an iterator. Okay, so this iterator is returned by another algorithm named find, and so this find algorithm also starts at the beginning and ending, in range from the beginning of and ending of fruit2, and finds element named peach. So here we have found it, and this line of course demonstrates the idea of iterator, which is a helper object in C++ standard library associated with containers, so that it's a pointer-like object, helper object, which remembers the container and the location of a specific element. So thereafter find is complete. Now we have an iterator named P1. Of course, P1 derives itself, an idea of naming it like this is like a pointer object. So it points, it knows the location of a specific element. So now we also create iterator P2, and P2 is the result of our search for watermelon. And then list operations that we're just about to actually start looking at. List operations are based on ranges of values, and also insertions and removals within these ranges, or given specific location of elements. So once we have the second iterator in place, they're specifying a range. In C++ standard library, ranges are half open ranges, so that the last element is not included in the range, just specifying the last element which should not be included in the range. So right now P1 and P2 really specifying the range which includes peach and pear, and watermelon is not included in that range. So finally, on the next line, we're going to erase element in this range, having these two iterators already created and knowing what the positions are. So erase essentially has to relocate watermelon, and notice that this iterator now, the range is no longer a valid range. So basically the iterators are always invalidated after mutating operation on your container. So of course using this iterator would be quite dangerous if you attempted to use it in some other context. So this is why we instantly reposition iterator P2 and say, let's actually locate watermelon again. And of course we know it was at the end, so it should find it now. So the second attempt to find watermelon is finding it as well, and then P2 is reset. So now we also can use another list example, operation example, erase with just one iterator P2. So this time we're just about to erase this last element. Okay, so the element is gone, and now P1 and P2 ending up having positions specifying the ending of this container. Of course, the end function of the container returns imaginary position, which is a position of an element which does not exist. And using the ending like this allows us to specify half open ranges, so that we can even express an empty range using this type of range. So then look, we are just about to relocate P1, iterator P1, to the beginning of fruit 2. So we say fruit P1 equals fruit 2 begin. So now this iterator understands that this is its new position. And now we can erase this element. So grapefruit is just about to be erased from the container. Okay, so of course this is not an operation which just takes the element out. In vector is guaranteed to allocate contiguous area of memory, so all the rest of the remaining elements have to be rearranged, they just shifted up. And by the way, again, P2 became dangling iterator, which is not very safe at all. So again, mutating operations could be dangerous for iterators that were positioned before an operation which updated content of a container has happened. So anyway, so we now have this, and we can also position iterators using arithmetics, just like we would do it with pointers. So here we'd like to say P1 to position it at position begin, which is the initial element, plus 1. So here we execute this, and here we just reset position of P1. Now also using this position P1, we're just about to insert cherry. So of course this happens like by again relocating some elements, providing space, and it's just like when you type in your source code editor new characters. The characters, if you're in the typical insertion mode of your text editor, the characters to the right when you type are pushed to the right. So here it's the same thing. It's just like inserting an element at the position Now P2 is going to be relocated, pointing to and -2, and -1, -2. So now P2 is pointing to Lime. And now we're going to insert Cranberry right at the position P2. So also insertions, erasures, and insertions are examples of container list operations. Okay, so we have 1, 2, 3, 4 objects so far allocated by this function, and once again in the order opposite to which they were created, which is basically fruit, then fruit2, then P1, and then P2. Now in the opposite order, these objects will be destroyed as soon as we reach the end of our function, the closing brace, which is responsible for destroying the stack frame on which this function was invoked, and that stack frame is hosting all local objects and variables. So you can see this order now. So they're just destroyed in exactly opposite order.